Okay, so let's take a look at now a different example where we're going to look at some multiplication. So previous video, we looked at these for Z5. Let's take a look now at Z6. So now let's try to solve the same equation of this relation class of 3 times x is equal to 2. So I'm using the other notation just so you can also see this. How does this work? So remember that when we're looking at things modulo n, we only need to check a certain number of values. So we just need to check these n choices of 0 up to n minus 1. So let's check to see what do I get when I multiply each of these by 3. So there's basically cases that I'm doing. I'm considering these 6 cases to see which of these are solutions. So if I take the relation class of 3 times 0, remember, we just are multiplying these. So we're just taking 3 times 0, and so this gives us 3 times 0, which is the relation class of 0. Obviously not the relation class of 2. Try this again. We take 3 times 1. This is the relation class of 3. That's not 2. Okay, try this now. 3 times 2, that's the relation class of 6. But again, that's not one of these. We're trying to bring it back between 0 to 5. Well, the remainder of 6, when you divide it by 6, is going to be 0. So this is going to be 0. If I do the same thing here, now this is the relation class of 9, but bringing this back into this realm, this is now going to be 3. This relation class is going to be for 12, but again, saying what's the remainder when I divide this by 6, I get 0. And then here I'm going to get 15. What is the remainder? I get 3. So notice what we have here is that when I multiply this 3 by all of these possibilities, I never get 2. Right? Never get 2. I got 0, 3, 0, 3, 0, 3. So here, what we see is that there is no solution. So I do not have a solution for this equation in Z6, so I'm multiplying them. But now let's say, what if I solve this equation of what solution is there for x? Well, normally when you're used to solving multiplication problems, let's say, for instance, I was to solve 3x is equal to 5, for instance, right, just using regular numbers, you would divide this over by 3, and you'd have x is equal to 5/3. That's cool. If I was to say 3x is equal to 0, I divide this by 3, x is equal to 0. Okay, I get these one solutions, right? Now, sometimes you might get no solutions, right? If you're dealing with just real numbers, for instance, like x squared is equal to -1, you solve this, you get no solutions. So that's fine. This idea over here maybe isn't that weird to have no solution. Now, obviously, for just regular multiplication, that doesn't exist in the regular real numbers. But here, now what happens is that what we notice from our example is that x is equal to the relation class of 0, right? When I picked this number, that worked. When I picked this one, it worked. And then when I picked this one, it also worked. So I have now multiple solutions of what solve this equation. Now, yes, you've seen multiple solutions when you're looking at polynomials, for instance, and you're looking at, say, x squared plus blah, 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 right? Then you can get multiple solutions that work. But in a regular multiplication here, there is not any exponents. So this is something that's very unique about modular arithmetic when it comes to multiplying, is that sometimes you get no solution. The example we did in the last video, we got one solution, and sometimes we get a whole bunch of solutions. Now, you're obviously never going to get infinitely many solutions because you're only ever going to have at most n solutions that work. But be aware that sometimes things are going to get a little funny when we deal with multiplication and this. And so there's a whole lot of advanced theorems about studying these properties of Zn, of what happens if n is prime, what happens if n is composite, what if we try to solve this where this number is relatively prime to n, You had that on a homework question a while ago where they share no common factors. There's a lot of really cool theorems on this, so this is just very much the tip of the iceberg. But it's a really good thing to get used to trying to figure out is, are there more than one solution? Because you can't just be done after one.